Hello everyone, welcome all of you to the deep dives. So I would like to thank all of you for your lovely love and support. So in this particular part, I'll be covering the raised question from the question 45 to question 48. Okay, so question 45, I would like to give you more analysis. Okay, give you more analysis as it is more important. In the texture also, as I have already discussed, texture is important for the GSI prelims as well as for the GSI mains, है ना? तो इसलिए क्वेश्चन 41 45 को, ये जो क्वेश्चन 45 है, I want to give emphasis. So in the next video I will covering the texture of igneous rock in the next part, not this part, in the next video. So texture of igneous rock, है ना? जैसे those the property like the diffusion, what do you mean by diffusion, what do you mean by nucleation, okay, how the nucleation affect in the rate of crystal growth, okay, and the different type of parameter like how the crystal growth and how the rate of nucleation will affect the cooling rate of magma, I will discuss in a broad manner in the next video. ठीक है, as I have said कि ये आंसर तो all of these है, क्योंकि rate of nucleation is also affect during the cooling rate of magma, diffusion rate will be the affect the cooling rate of magma, है ना? ये मैं पिछले वीडियो पे बता चुका हूँ already. So without further delay I will be discuss about question number 46 onwards. ठीक है, question 45 के लिए for the time being I will stop for now. In the next particular part I will cover in a broad manner question number 45, है ना? So let's start the question. So in the Mg2SiO4 and silica binary phase diagram at 1 atmospheric pressure, that means pressure is constant, right? You know, in the all the phase diagram, be it binary or be it ternary, so assume there will be the pressure constant, that means isobaric system. So pressure is constant here, so that's why we apply the condensed phase rule, you know, we apply the condensed phase rule. Don't be confused. So P plus F will be C plus 1. So this is the condensed phase rule or modified phase rule. It is called modified phase rule or condensed phase rule. I'll discuss the different type of numerical on the basis of the condensed phase rule and the normal phase rule. How you apply the different type of numerical in modified phase rule, ठीक है, और in the normal phase rule. Suppose एक numerical पे दिया होगा कि assume the pressure is constant, that means you apply the this equation, not the normal equation like P plus F will be equal to C plus 2. ये apply नहीं करना है, you have to apply the condensed phase rule. Okay, so in the Mg2SiO4 frostite silica, so this is the frostite and this is silica binary phase diagram. You know, it shows the peritectic behavior. When the liquid reaches the point X at 1550 degrees centigrade, it begins to react with the crystal of frostite to form enstatite. Okay, and the liquid remains at point X until the enstatite forming reaction has gone for the completion. What is the point X is called? Let's see. Okay, so this is the all about 1557 degrees centigrade. Okay, so this is the frostite, this is enstatite, and this is silica. This is not the ternary phase behavior, है ना? Don't assume it is the ternary phase behavior due to the presence of enstatite. It is two component system. Here the component will be two. The frostite is one component and silica is one component, not enstatite. As frostite and silica will not normally occurring in the nature, so the enstatite will form, you know, right? Enstatite is equal to frostite plus silica, right? When frostite and silica get react with each other, it forms the enstatite. So enstatite is the intermediate product. So if the 1557 degrees centigrade, suppose assume the melt, having some composition. ठीक है, अगर इसको कूल करते जाओगे, when it reaches the 1557, see at this 1557 the unstratigraph will form, right? Unstratigraph will join this point, no, K point को touch किया है ना, so unstratigraph will join at this particular point. So यहाँ पे तो already frostite होगा, क्यों? When the X point or X, this is the melt composition, when it touches the liquidus, so this is the liquidus, when it touches the liquidus the frostite will start crystallizing. So in the system, no, the frostite will be there, है ना? So frostite will be there and liquid also there. When it reaches the particular point at 1557 at K point, ये देखो J, K and I will be collinear, है ना? J, K and I. So J point means frostite, K point means unstratigraph and I point means, so this is the peridactic point. I point is the peridactic point, है ना? So when the frostite and liquid will react, okay, gives the unstratigraph. Frostite and liquid react with unstratigraph, ठीक है, at 1557 degrees centigrade. So this is the peridactic point, right? And this is the eutectic point. Okay, eutectic point. Okay, so at 1557 is the peridactic point where the unstratigraph will form. Okay, because in previous the frostite will be there, है ना? Liquid भी है क्योंकि this particular melt phase तो already है ना. So frostite and liquid to form the unstratigraph, ठीक है? At peridactic point also degree of freedom will be 0, right? I will upload the videos of the igneous binary peridactic behavior, है ना? Like crystallization behavior and melt behavior of the magma. So I will upload gradually, don't worry about it. All the like igneous video lecture I will upload gradually, from the texture, the form, structure, right? So differentiation, assimilation I will upload gradually, so don't worry about it. But for the time being, just know that at peridactic point degree of freedom will be 0, because here the 4 phase will exist, no? Okay, frostite भी exist करेगा, unstratigraph भी exist करेगा, not 4, 3, right? And liquid also there. So if you apply the condensed phase rule, P plus F will be C plus 1. The component will be 2 plus 1 and 3. Phase will be 3 because frostite is one phase, unstratigraph is one phase, liquid will one phase. 3, so 0. Degree of freedom will be 0. So it is invariant point. Invariant point. When the degree of freedom will be 0, it is called invariant. Okay, let me add some more pages and also that I can write. ठीक है? When the degree of freedom will be 0, मतलब peridactic point को invariant point बोलते हैं. So that is called invariant point. ना? When degree of freedom will be 1, so it is called univariant line. Okay. When the degree of freedom will be 2, it is called divariant field. ठीक है? Okay. So at 1557 will be the peridactic point. So right answer will be B. Okay. Hope you should understand this part. Okay. I will upload some of the video of the different type of phase behavior like eutectic behavior, peridactic behavior, solvers. Next, go to the next question. Question number 47. Okay. Consider the following 4 geochemical reservoirs. So it is from the mantle reservoir. Question from the mantle reservoir. See, if you look at the syllabus, no, there will be the no mantle reservoir is there, right? Only their magma, their evolution is there. And this type of mantle reservoir, no, should be correlate with the isotope geochemistry. If you understand the SR isotope, RBSR isotope and ND, okay, niobium isotope, then you should understand the proper isotopic evolution, how it is evolved. Okay, let's go to the next part. Okay, so consider the four geochemical reservoir. One is the depleted mantle, one is enriched mantle 1, one is enriched mantle 2, one is continental crust. So let's first discuss the what are the different type of geochemical reservoir. Okay, so what are the different type of geochemical reservoir? Okay, geochemical reservoir, and what do you mean by exactly the depleted mantle and enriched mantle 1 and enriched mantle 2 and continental crust. Okay, so identify correct code as per there based on the 87 SR and 86 SR ratio. Okay, so this is the plotting between the 143 ND, 144 ND and 87 SR upon 86 SR. Okay, as you know, so this is the bulk silicate earth, and this is the plot between the bulk silicate earth. So what do you mean by bulk silicate earth? It is nothing but the earth without core. Without core. For now, like no such type of reservoir existing today. No such type of reservoir existing today. Okay, let's discuss about what do you mean by depleted and what do you mean by enriched source. Let's discuss first. Okay, let me add some more. Yeah, so now it's fine. What do you mean by enriched source? Enriched in what? Okay, and depleted in what? The source that is rich in incompatible element. Rich in the incompatible element. Incompatible element. Okay, what are the different type of incompatible element? Like potassium will be there, barium will be there, rubidium will be there, niobium. So this is the incompatible element. An incompatible and compatible element is based upon the how it is distributed, or it depends upon the chemical fractionation of element. Okay, what do you mean by incompatible element? So during melting, what happens is during the partial melting, the element goes to the liquid phase. Okay, go to the liquid phase. Some of the element is called incompatible, and compatible, some of the element will go to the solid phase during the partial partial melting. So that is called the incompatible and compatible element, and also it depends upon the distribution coefficient. Distribution coefficient मैं अभी बताया, it depends upon the chemical fractionation of element. Distribution coefficient. Okay, so enriched source मतलब जो source reached in the incompatible element, that is K, Ba, Rb and niobium. What happens is during the melting, during the metal melting, some of the element will be rich in the incompatible element, like potassium, barium, rubidium and niobium. It is called the enriched source. Like what are the source? Continental crust. Continental crust is rich in the incompatible element. Rich in the incompatible element, because what happens is when suppose मान लो कि when the Rb decays to Sr, है ना, so 87 Rb, it is called the 87 Sr. Let me erase this part. Okay, so 87 Rb decays to 87 Sr, and you know 86 Sr is stable, right? So that's why we are taking the ratio of 86 Sr. So 87 Sr by 86 Sr ratio is the environment. Okay, if the continental crust made up of the niobium and RB element, that means the ratio should be high, right? 87 SR by 86 SR should be high, right? Because during the partial melting or like the during the metasomatic, due to the metasomatism of aqueous fluid, it is enriched in the incompatible element. So it is called the enriched source. And what about the depleted source? What about depleted source? Let's try. Depleted source क्या है? Depleted in incompatible element. That means pour in incompatible element. Pour in incompatible element. ठीक है? So ये डिप्लीटेड सोर्स आपका हो गया, ठीक है ना? जैसे एग्जांपल मेंटल और मेंटल, इट इज द डिप्लीटेड सोर्स, है ना, ड्यू टू द प्रेजेंस ऑफ लो आरबी. यहाँ पे रीच होगा, आरबी विल बी रीच, ठीक है, बट द इन द डिप्लीटेड सोर्स द आरबी विल बी द लो. सो दैट्स व्हाई व्हेन द 87 आरबी डिकेज टू 87 SR, so the ratio of 87 SR to 86 ratio will be low in this particular part, depleted source, है ना? Because what happens is previous melt extraction which has the removed the incompatible element, right? So क्या होता है normally, अगर सारे extraction हो गया है, there will be the no incompatible element remaining, right? The previous melt extraction अगर सारे melt which has removed the incompatible element, so that's why it is depleted source. That's why. समझ में आ गया? So if you look back, see, so it is the bulk silicate art. So this is the cross section or like intersection, not cross section, it is the intersection point that represent the bulk silicate art, ठीक है? See, the D point is the continental crust, है ना? D is the continental crust, ठीक है? D is the continental crust, so D will be the 4. So D will be 4. Let's cancel this part. Why D is 4? Because see, the ratio will be high, as I already have stated that 87 RB decays to 87 SR, ठीक है? तो RB will be reached in the enriched part, enriched source, that is in the continental crust, है ना? अगर RB enriched होगा, that means the ratio of 87 SR to 86 SR will be high in the continental crust. So D will be the continental crust. So either the answer will be the A or B. And this part, no, from this, so this represent the depleted field, and this represent the enriched field, है ना? So see, and enriched mental 1 will be higher, okay, higher the incompatible element than the enriched mental 2. See, it depends na, it depends upon the ratio, and how much is the 87 SR and how much is the 86 SR will be there in the system, and how much is the 143 ND and 144 ND respectively, ठीक है? कितना ratio है depending upon the experiment. So it is the plot, simply it is the plot between those type of ratio, ठीक है? तो let's see, ये देखो, so this is the depleted mantle and this is the bulk silicate, and this is the enriched mantle, okay? So it depends upon the ratio, ये देखो, so this is the bulk silicate ना, this ratio and this ratio, it approximately 0.705, right? So this ratio tells about the bulk silicate earth and the enriched source and the continental crust. See, ये हो गया मेडोसनिक रीच बासाल्ट अपर मेंटल, that is the depleted source, है ना? And the continental crust is the higher, like this is the more enriched source, So source has been taken from the WT void. It is present in the book. Okay. And enriched metal 1. So this is the enriched metal 1. Abhi bataya enriched metal 1. And this is the C is the enriched metal 2. So A will be 1 because it is depleted. See, in the both A will be 1, right? And B will be 2. So A will be the right answer. Bataya na? So this is the more enriched. If you look the literature, अभी बताया. So what are the different type of incompatible element? क्या होता है incompatible element? क्या होता है? It depends upon the distribution coefficient. Any chemical fractionation. Okay, it depends upon the distribution coefficient, that is activity of the solid upon the activity of the liquid. That means concentration of the solid upon the concentration of the liquid. It depends upon the K value or KT value. Okay, it depends upon the distribution coefficient. So incompatible element are concentrated in the melt. During the basal melting, what happens is some of the element will go to the melt phase or liquid phase. It also depends on the distribution coefficient. So how much it distributed between the solid and liquid phase. Okay, so concentration of the solid and concentration of the liquid. So if it is the less than 1, it is called the incompatible. If it is greater than 1, it is called the compatible element. Okay, so see the depleted metal, high 143 Nd by 144 Nd, low 87 SR ratio by 86 SR ratio will be the low. Okay, so depleted metal will be 87 SR by 86 SR ratio will be low. So it is nothing but like literature. So and the experiment. Okay, so enriched metal 1 will be low 87 SR and 86 ratio. Similarly, enriched metal 2 will be the higher 87 SR by 86 ratio will be the higher side. So that's why I have stated that B will be the enriched metal 1 and C will be the enriched metal 2. It depends upon the ratio. Simple. 87 SR by 86 SR will be the higher side or lower side. If it is low, then it is called the enriched metal 1. Okay, it is low ratio and C will be the high ratio. Clear? Okay, enriched metal 2 and the Prima model, it depends not only the 143 Nd and 144 Nd ratio, it also depends upon the PB ratio. Okay, so 206 PB by 204 PB. Okay, prevalent metal component will be there. Okay, let's go to the last question. So this is the last question. See, if this question is slightly tricky. This question is slightly tricky. Don't attempt this type of question, because what happens is, see, this is not like from the igneous petrology, or it is the correlation between the geochemical interpretation and the igneous petrology. Okay? It is not like particular igneous petrology. UPSC-GSI ask in the broader syllabus. Okay? So it is the correlation between the geochemistry and like geochemical interpretation, and from the tectonic, how the different type of tectonic setting is like and their geochemical interpretation. Okay? In different type of tectonic setting पे क्या क्या हमको element मिलेगा, and what about their signature, and what about those type of interpretation is based upon these question. Okay? So which one of the following rocks shows the high LILE? So this is large iron lithophile element and HFC. So it is the high field strength element. High field strength element. See, this is very tricky, even if I don't understand this particular question, because whether is this asking the question about that large iron lithophile element and HFSC ratio will be higher, or high Li will be there and high slash HFC will be there higher. See, this is the case 2. That will be the case 2. Even if I don't understand this particular question, what is the exact meaning of question, whether the UPSC-GSI is asking Li, Le by HFS will be higher, or there will be the LIL will be the higher and HFS will be the higher slash. Okay, doesn't mean the proper like question. ठीक है, कभी कभी जैसा ऐसे क्वेश्चन पूछता है कि लिटरेचर ठीक से मतलब जो इंग्लिश लिटरेचर है, द फ्रेमिंग ऑफ द क्वेश्चन इज स्लाइटली डिफिकल्ट टू अंडरस्टैंड द प्रॉपर क्वेश्चन. ठीक है, सो देखो पहले तो ये चीज देखो, don't, so this is the question from the geochemical interpretation. If you go to the Rawlinson paper for the geochemical evolution and the analysis part, there are lot of diagram, okay, like geochemical multi-element analysis and major element analysis, rare earth element analysis, the spider plot. So this is from the spider plot. If you understand the different type of ratio and understand the spider plot, if you see, if you go to the paper, Rawlinson paper, see the trend of the RE plot, trend of the spider plot, you will find कि anortho side will be the high LIL and HFS ratio. Okay, you will find in the Rawlinson paper. But according to me, Lamprey will be the maybe the answer, maybe. Why not Miocenic ridge basalt? See, it is from the subduction signature, right? So Miocenic ridge basalt and continental floored basalt, ये तो cancel ही हो गया. And a continental floored basalt will be the normally not answer, and major Miocenic ridge basalt will be the not be the answer. क्यों? अभी बताया. As the question says about the subduction setting, ठीक है ना? So Miocenic ridge basalt तो नहीं हो पाएगा, ठीक है. And what about the continental floored basalt? Same, will not be the answer, ठीक है, in the subduction signature. And also I already have told कि in the subduction signature what happens is the, if you go to the alkali series, ठीक है, igneous series मैं बताया था calc alkaline magma. See, let me add some more point. मैं क्या क्या बताया था? So मैं क्या बताया था? In the subduction zone. So फर्स्ट तो कैंसिल हो गया, Miocenic ridge basalt तो नहीं हो सकता है, कॉन्टिनेंटल फ्लोर्ड बासाल्ट भी नहीं हो सकता है ना, ये दोनों कैंसिल हो गया. रिमेनिंग विल बी either the lamproite will be answer, either the anorthosite will be the answer, ठीक है. But if you go to the paper of Rawlinson, there will be some interpretation or like, so this is the concentration, this is the rare earth element, LILE and high field strength element will be there, like there will be the some this type of diagram, spider plot diagram. If you see the in the anorthosite, the ratio will be higher, anorthosite ratio will be higher. It depends upon the concentration and the rare earth plot, LILE and high field strength element plot. If you go to the Rawlinson paper, you will find the anorthosite will be the answer, ठीक है. But don't worry. So in the subduction zone, I already stated कि calc-alkaline rocks will be the characteristic of the subduction zone. In question number I think 40 पे बताया था डिटेल, ये जो बताया था why the calc-alkaline rock will be the characteristic of the subduction zone. That means the andesitic type of rock will be the typical characteristic of the मतलब subduction zone, है ना, बताया था. So what if you see the anorthosite, it is the feldspar, right? Plagioclase feldspar ridge. Just draw your intuition based upon the intuition, ठीक है. मैं तो अगर इस टाइप का क्वेश्चन अगर अपेयर करेगा, don't attempt this type of question because it is slightly confusing, है ना. So plagioclase feldspar will not be the answer, right, if you see from this type of intuition, because in the subduction zone it is not trace element. I'm not talking about trace element. If you see from the igneous rock series, calcalkaline rock will be the typical characteristic of the subduction zone. Okay, so that means the andesitic type of rock. So it is not andesitic type of rock, right? So it made up of the plagioclase feldspar. So that's why I will say lamproite will be the right answer. And why lamproite? Lamproite will be the ultra potassic rock, है ना? Ultra potassic rock. So that means the K will be the higher, right? K2 will be higher. If you see also na, Li, Le and HFSC ratio will be higher. That means the Lil element will be the higher, है ना? Li element कौन सा है? ये देखो. So incompatible element commonly two subgroups. So incompatible element को हम डिवाइड करते हैं बेस्ड ऑन द फील्ड स्ट्रेंथ, बेस्ड ऑन द फील्ड स्ट्रेंथ, है ना, बेस्ड ऑन द फील्ड स्ट्रेंथ, और दैट इज कॉल्ड द आयनिक पोटेंशियल भी बोलते हैं. ठीक है, बट डू मीन बाय फील्ड स्ट्रेंथ? दैट मीन्स इट इज द रेशियो बिटवीन द आयनिक चार्ज एंड साइज, दैट मीन्स रेडियस. ठीक है, सो इट इज द प्लॉट बिटवीन द आयनिक चार्ज एंड आयनिक रेडियस. ठीक है, इफ देयर विल बी द हाईली चार्ज्ड, so that means the high field strength element. See, so this is called high field strength element and this is called LILE element. See the different type of example of element. So K will be there, RB will be there. See, in the lithopyle element K will be the example, na? Potassium, it is more mobile if the fluid phase is involved. So that means the LALE, large ion lithopyle element, upon HFAC ratio will be higher, right? So that's why I will say lamproite will be the right answer. Okay, why not anorthosite? And anorthosite is not the characteristic of the subduction zone also. ठीक, and LILE पे ये देखो, LILE पे large ionic size, low charge, and the ionic potential also less than 2. So this is the ionic potential line. If it is less than 2, it is called LILE. If it is greater than 2, it is called high field strength. Okay, so answer will be the lamproite will be the right answer. But if you go to the Rawlinson paper, it is stated anorthosite from this plot, you know, from this type of spider plot, anorthosite may be the higher type of ratio. Okay, if there will be this type of question in near future, don't attempt. My suggestion is to don't attempt this type of question. Okay, maybe anorthosite, maybe lamproite will be the answer, but my suggestion will be the lamproite will be the answer. Okay, instead of anorthosite. Let's see in the answer key, whenever the answer key will publish, let's see what will be the answer. So that's all for this video, because I have already completed, and one more question is remaining, that is question number 45. So in this next video I will discuss in a broad manner question number 45. What is the nucleation, how the rate of crystal growth will affect the cooling rate of magma. So I will discuss in the next video. So that's all from my side. So hope so you like the analysis in a detailed manner. So please like the video and comment below whether the analysis is good or like added value for your examination or not. So let me know in the comment section. So that's all. So thank you for your time. Thank you so much. Finally, thank you all.